Everyone, and welcome to the last video of the year for you. The last final lessons will be done in class. So we're looking at the idea of area between two different curves, and we've done this but just looking as the other curve being the x-axis. So if we look at the first one, if f of x equals x plus 3, find the exact area under the curve from 1 to 4 using a known geometric formula. Well, I've already drawn it for you. We have basically a base here, two straight lines, even though they're not straight on here, with a slanted top. That is called the area of, this is called a trapezoid. And so the area of a trapezoid is 1/2 base times height 1 plus height 2. And so we've got to figure it out. Well, we're going to figure out the heights by using the formula 1, 4 and 4, 7. And so we know for this 1/2 base, the base is 3, times the height of 4 plus 7. And we're going to get 1/2 times 3 times 11. And so we're going to get 33 halves. And so that's it. That's the area. Now, with that, we could have done the same thing as just saying the integral from 1 to 4 of x plus 3 dx. And you would have gotten the same idea. Now, in this next one, we can't use a known geometric formula because it's a slanted or curved line. And so we'll find the exact area by using the integral. So the integral from 1 to 4 of x squared dx, we know that's x cubed over 3 from 1 to 4. Bring out the 1/3, and get 4 cubed minus 1 cubed, and we'll get 1/3, 4 cubed is 64 minus 1, 63, and that's going to be 21 is our total area. The whole idea here is based that the area under the curve is the integral from those bounds, which you guys have already learned about, and we've done many, many times. So the final concept that we're going to be learning about integration is the area between two different curves. So we have here a linear function and a quadratic. If we're looking, let's just state that we're looking from here to there. I know they're not exact, but we'll just call it A to B. And so if I take the area of this, I'm going to use vertical lines here. That's the area of f of x from A to B. And then if I take the area under g of x, we'll call g of x this, the quadratic. The area there is this and that. If I take that area, the red part, and subtract it from the penciled part, we're left with this area of the highlighted part. And that's the area that is between those two curves, the area that's encased by those two curves. And so how did we do it? We took the area of the quote top curve, I don't like to call it that, but the top curve, subtracted by the area of the bottom curve. So we took the area of the entire penciled in region, subtracted from the red region, and we got the highlighted region. And that's all it is. It's the entire idea. Top minus bottom integral from the intersection points. A and B are where the two curves, the two functions we'll call it, two functions intersected. Okay? The joke from today, or for today, your final one, why did the golfer bring 2 pairs of socks? In case he got a hole in one. You can thank one of your students for that one, giving that to me. Appreciate it. I thought it was a good one to end off on. So in this case, we'll go back to calculus. I thought it was a good joke though. Find the area of the region bounded by y equals x plus 6 and y equals x squared from 0 to 2. Now notice here is that it's not necessarily where they intersected in this case. It's just telling you find this area right there. Well, our top curve is x plus 6. Our bottom curve is y equals x squared. And so we're going to subtract them. The integral from 0 to 2 of parentheses x plus 6 minus x squared dx. And I'm going to allow you to use your calculator on this, and let me show you something here. To make your life very easy, or much easier I should say. In y1 you're going to put the top curve, x plus 6. In y2 you're going to put the bottom curve, x squared. It really doesn't matter which one you put them in, but it'll make your life easier. Then we're going to use the math9 function. So math9, which is the integral function, from 0 to 2. You do not need to show work on this. This is why I'm telling you this. The key here is that to get to y1, you're going to use second or alpha trace y1, enter, minus alpha trace y2. Come on. There you go, y2. And make sure you're in x there. And this will give you the answer. I do not need to show work down. You do not need to show work. All I do is need to see the integral and then the answer. Again, you want to put it into exact form, so that's 34/3. Sometimes the calculator will not necessarily give you the round it here, which won't allow you to put it in the fraction form. You need to just retype it as that. So if there had been if this had been 6666667, then you would have just needed to type in 11.66 to get the answer. Okay. So in this case, we are not told where they intersect. So we have the same two functions. In this case, though, we're just saying where is it bounded by. We're not given an interval. So we need to find that point and that point. Two ways to do that. You have your calculator, but there's also set them equal to each other. We want to know when they're equal, when they intersect. So x squared minus x minus 6 equals 0. Factor that. So you know that's x equals -2 and x equals 3. And so now we know we're looking at the integral from -2 to 3 of x plus 6 minus x squared. I can make my x's, that would be helpful. How long have I been doing this now? Dx. And I'm going to go back to my calculator. Math 9 of -3 to 2 of y1 minus y2 x, enter, math, enter correct, and 95/6. There it is. With this one, we have two functions here already graphed out for you. We need to find where they intersect. No, we don't. We are already given that. X equals -2 to 2. So we don't need to do this. Don't worry about it. We got to figure out which our top function is. Square root of 2 minus x. Our bottom function, -x. So the integral from -2 to 2 of square root of 2 minus x minus -x dx. And so all we're going to do here, I already have it in here, y equals, it's already in there. So we're going to take math 9 from -2 to 2 of y1 minus y2 and wait, and I think this is the one that will not allow you to do it. This is what I want to show you. So I'm going to go back in there, just type 5.333 and get 16/3. Okay, so that's the example right here. If it does not end nicely, you know it's 5.3333. Calculator just made a little error in the estimation. So this final one is going to show you a little bit of an issue and a more complicated problem here. That's the area shaded by these two curves, y equals x minus 2 and x equals y squared. This should be a big red flag for you. X equals y squared is not in terms of y. If we solve for it in terms of y, you get plus or minus square root of x. This right here is y equals square root of x, and that right there is y equals a negative square root of x. Sideways parabola. So what we've got here is if I want to find the area of this, I'm looking at three different functions. This one, and that one. The first area, and this is important to see, is broken up right there. This is one curve, another curve. This is our first integral. Our second integral is going to be here and over by using those two functions. It was cut off at 1, and so therefore we need to have two separate integrals, 0 to 1 of square root of x minus negative square root of x dx plus the area that's highlighted in yellow, which is again the top one is square root of x, the integral from, where does it stop? We got to probably figure that out. 1, 2, 3, 4. So the integral from 1 to 4 of square root of x minus 2 dx. That's how we would split it up. And you can use your calculator and get an answer. The answer should be 9/2 if you did it out. Let me show you a little bit of an easier way to do that. That's why I'm giving you the same problem on the back. What we did here was use vertical lines to find the area. We found the area of the top minus the bottom. On this case, if we change it to find the area using horizontal lines, notice that the curves that we use never change. This whole parabola here, which is sideways, if we're in respect to y, is x equals y squared. And this line, the red line, that I can't trace very well, if we solve for x, is x equals y plus 2. Now I have the top minus the bottom. Top, the one that's farthest out, one that's the greatest, minus the one that's the smallest in terms of the distance away from the y-axis. In this case, we can now write it out as the greatest one, y plus 2, minus y squared. And this is now in terms of dy. And the key is that we need to figure out what is that point and what is that point for y. So if we solve them, you are going to get 4, 2 and 1, negative 1. And if you need to know how to do that, we just set these equal to each other. Y squared minus y minus 2 equals 0. And so you get y minus 2, y plus 1. And there's where you get your 2 and your negative 1. And so you may be thinking, what do you do with y in the calculator? Well, all you're going to do is plug it in just like you would with x's. So you're going to get, again, math 9. We're going to go from negative 1 to 2. And you'll get 9/2. I hope that these videos have helped you. and it's been fun to make them, and good luck as you go to college next year.